The undergraduate admission rate at a certain university for a certain year was 6%. And part A asks, what is the probability that exactly 5 out of 100 applicants will be admitted or accepted into the university? Oh, and up here says assume that decisions to admit are independent, which I think is a reasonable assumption. So this is a binomial probability experiment. So what I'm going to do is open up StatCrunch and use the binomial calculator to get my answer. So in question help, I'll go to StatCrunch. And to get the binomial calculator, you go Stat, Calculators, and select Binomial. Okay, what we want to enter here is, first of all, for n, that is the total number of applicants here, which is going to be 100, so that'll always be the total number in the experiment. The probability p for success is 6% or 0.06. And the probability that exactly 5 will be admitted would be if we put equal and then 5. And it already computed this for us. And if we round to 3 decimal places, we get 0.164. So 16.4%. For part B, it says, what is the probability that exactly 95 out of the 100 applicants will be rejected? So it's a different thing that they're asking for here. Here this is, admitted in 5 of the 100. Down here we're saying rejected, so obviously not admitted, but we're talking about the, remaining, it's like the other 95 that we didn't consider up here. It kind of stands to reason that I think this should be the same answer. It should also be 0.164. Let's verify this by going back into StatCrunch and thinking of how we can get that value from this calculator. A few things are changing though. For starters, well, n equals 100 does not change. But here we're talking about rejected. Well, if 6% are accepted or admitted, then it must be that p is equal to 94 because the other 94% would be rejected. So that's different here since we're talking about rejected instead of admitted. Furthermore, I have to change this number too because it's saying, well, what's the probability that exactly 95 will be rejected? So it's got to be equals and 95. And we click compute, and we actually get the same number as last time, which is not really a surprise. And if I round that to 3 decimal places, that is 0.164. I'll check my answer, and that's it for this problem.